A farmer in Colombia woke up yesterday and his field was on fire. No lightning, no electrical fault, the ground itself just exploded. Methane, shooting up from miles underground like a blowtorch. And here's the crazy part 27 days earlier. The exact same thing happened. On the other side of the planet, Azerbaijan, massive fireball. 2 continents, less than a month. And right now, a NASA spacecraft is diving into the sun at 430,000 miles per hour. And the data it's collecting might explain why the Earth is literally blowing up. Stick with me. By minute 6, I'm going to walk you through the exact chain reaction step by step from a solar flare 93 million miles away to a methane fireball in somebody's backyard. And at 3:30, there's a detail about the Voyager probes that most people completely overlook. It'll rewire how you think about time. Don't skip ahead seriously. It hits different when you hear the whole thing in order. Okay, so February 26th, Bolívar Province, Colombia, this mud volcano, and yeah, that's a real thing. We'll get into what it is in a sec. Geologists actually classified it as small, and yet this tiny thing produced an explosion big enough to evacuate entire villages and wipe out livestock on the spot. Not lava, not magma. We're talking about methane, a gas that's 80 times more potent than carbon dioxide as a greenhouse. Gas just rocketing up from deep underground, hitting the surface, where it's hot enough to ignite, and boom, just like that, gone. Now here's what should freak you out a little. Methane actually packs more explosive punch than gasoline per unit volume. The stuff under your feet right now is basically pressurized rocket fuel. That makes what's in your gas tank look tame. And Earth's been burping it up more and more. But look, here's what nobody's connecting. Rewind 27 days, January 30th, Azerbaijan. This is the country with the most mud volcanoes on the planet, over 300 of them. One of those went off in the middle of the night. Methane shooting up, catching fire, lighting up the sky like a war zone. People could see the glow for miles. So we got 2 massive explosions, 2 different continents, under 30 days apart. Coincidence maybe. Could be, but there's a hypothesis out there that connects them. And it starts not underground, but 93 million miles above our heads with the sun. I know. That sounds like a stretch. But stay with me because I need to take you somewhere that's going to seem totally unrelated for about 3 minutes. And then at minute 6, every single piece is going to snap together like a puzzle. You'll see. So right now there's a spacecraft called the Parker Solar Probe, and it is closer to the sun than anything humans have ever built, like ever. It's reached its final orbit, no more. Gravity assists from Venus or Mercury. It just dives in, gets blasted by 2,500 degree Fahrenheit temps, grabs its data and swings back out to cool down. Then does it again and again. Absolute beast of engineering. But here's where it gets genuinely wild. When Parker finally runs dry on propellant, NASA isn't just going to let it die quietly. Nope. They're going to flip the whole spacecraft around so the heat shield is no longer protecting the instruments on purpose. They'll let the sun cook the probe alive piece by piece while recording exactly how every component melts, warps, and breaks every metal, every sensor, every slab of glass. When the lead engineer on that project was asked what happens when the probe dies, the answer was, basically, that's when the real experiment begins. That's cold. I love that. But okay, why should you care about any of this? You're sitting in your living room. What's a spacecraft near the sun got to do with you? Everything. Because Parker is studying the solar wind that's the stream of charged particles the sun blasts at us nonstop. And when the sun has a really bad day, when it launches what they call a coronal mass ejection, billions of tons of magnetized plasma come screaming toward Earth at up to 6.7 million miles per hour. That's the trigger. Hold on to that. We're coming back to it at minute 6, and it's going to change everything. But first, here's that Voyager, the thing I teased you about, and honestly, this one messes with my head every time I think about it. Both Voyager 1 and Voyager 2 are still out there right now. Voyager 1 is over 15 billion miles from Earth. It literally left our solar system. It's in interstellar space, been flying for nearly 50 years. And here's the part people sleep on. If you could somehow get out there and look at Voyager today, you'd still recognize it. Some bleached paint from decades of radiation. A few tiny dings from micrometeorites, but structurally, basically mint condition. Scientists estimate those golden records, the gold-plated discs carrying Chuck Berry, whale songs, a baby's first, cry, greetings in 55 languages will still be readable 1 billion. Years from now, 1 billion years, long after the last human is gone. Those disks will still be drifting through the Milky Way, carrying a baby's cry into the dark. That's either the most hopeful or the most heartbreaking thing our species has ever done. I genuinely don't know which one. But think about why that's possible. Deep space is weirdly the gentlest environment there is. Almost nothing to hit them. No wind, no water, no erosion, just silence and vacuum forever. Now flip that. Compare it to what's happening 6 miles below your feet right now. Crushing pressure, 400+ degree Fahrenheit temps, corrosive salt water, laced with dissolved gases chewing through solid rock, and methane, compressed under insane pressure hunting for any crack, any fault line, any tiny weakness to blast through and explode at the surface. Same universe, two completely opposite worlds up there. Human. Stuff survives 1 billion years. Down here, the planet is ripping itself apart from the inside, and the thing connecting both the sun don't go anywhere. This next section is the payoff. Quick detour though. I gotta mention this because it matters. The space station, it's been getting pelted, pockmarks all over its solar panels. The James Webb Telescope, our $10 billion baby, already got whacked by a micrometeorite. So big NASA had to literally change which direction it points. And there are over 10,000 satellites up there right now. Could hit 1 million within decades, each one dimming the sky for every telescope on Earth. And yet right now we're building the most insane ground telescope in human history. The extremely large telescope, 128 feet across, being built in Chile. 6 times wider than Webb, costs 1.5 billion euros. Webb costs $10 billion. This thing fires an army of lasers into the sky to create fake guide stars, then bends its mirror in real time to cancel out atmospheric blur. It'll perform like a 128-foot telescope floating in space on the ground. Keep that in your pocket. We're coming back to the ELT later, and it ties into the methane story in a way you won't see coming. Okay? Minute 6, here's your payoff, the chain reaction, sun to explosion. 5 steps, here we go. Step 1, the sun throws a tantrum, it launches. A coronal mass ejection, billions of tons of magnetized plasma hurling toward Earth at millions of miles per hour. Parker's solar probe is out. They're studying exactly why and how the sun does this. Step 2, that wall of plasma slams into Earth's magnetic field. The field goes haywire. This is a geomagnetic storm. Up top, you get the northern lights. Pretty. Right, great for Instagram. But underneath your feet, something very different is happening. Step 3, and this is where it gets spicy. Deep underground, there are massive networks of hydrothermal fluids, hot, salty water carrying dissolved gases, including methane. Now, these fluids are electrically charged because of all that salt. So when the magnetic field above them starts flipping out during a geomagnetic storm, these charged fluids can actually resonate with the fluctuation. Now, full transparency here, this is still a hypothesis. It hasn't been fully proven, but the correlation is striking enough that geophysicists are actively chasing it. Think of it like shaking a bottle of Coke. The geomagnetic storm is the shake. The methane is the fizz. Step 4, the disturbed fluids push methane out faster. Big bubbles form. They rise through natural conduits in the crust, the same pipes that create mud volcanoes. Step 5, that methane hits the surface. The surrounding material is hot enough to ignite it. Boom! Fireball. That's what happened in Azerbaijan on January 30th. That's what happened in Colombia on February 26th. Sun to explosion. 5 steps. And here's what should really keep you up at night. The sun operates on an 11-year activity cycle. And right now we're smack in the middle of solar maximum. The sun is angrier than it's been in over 20 years. More flares, more coronal mass ejections, more geomagnetic storms hammering the planet, and potentially more methane getting shaken loose from deep underground. Now pile climate change on top of that, and yeah, it gets ugly. Here's the deal. Permafrost. You know the word permanently frozen ground in Siberia, Alaska, northern Canada. Except it's not so permanent anymore. Temps go up. Permafrost thaws. And methane that's been trapped for thousands of years just escapes. In Siberia, researchers have found craters, hundreds of feet deep, blown out from below by methane explosions. The ground literally collapses, and in the oceans, methane bubbles up from the seafloor in volumes large enough to theoretically sink ships. That's actually one of the real scientific ideas behind the Bermuda Triangle massive methane burps reducing water density so fast that boats just lose buoyancy and drop. Wild, right? So here's the feedback loop from hell. Planet warms, permafrost melts, methane escapes. That methane traps 80 times more heat than CO2 over 20 years. Planet warms faster, more permafrost melts, more methane, more warming. Meanwhile, the sun is simultaneously stirring up deep hydrothermal systems through geomagnetic storms, shaking loose even more methane through mud. Volcanoes. Two forces hitting the same gas from opposite directions. One from above, one from within, both speeding up, and literally nobody in mainstream media is talking about them together. Okay, but here's where this story takes a turn you probably don't expect. If you've made it this far, you're about to hear the most counterintuitive thing in this whole video. Ready? We've already started building the solution. And I bet you anything you've never heard it put this way. We're building a Dyson Sphere. Right now. Today. Not some sci-fi megastructure around the sun. I mean literally every single satellite in orbit that runs on solar panels. That's a piece of the Dyson Sphere. Each one catches photons that would have disappeared into deep space and turns them into useful work. GPS, Netflix, you name it. Right now, humanity captures maybe 1/quadrillionth of the sun's energy. That's a 1 with 15 zeros. Under it, practically nothing. But think about this, a single solar farm in space the size of a football field could power about 35,000 homes. Now imagine 10,000 of those, 100,000. Every year we launch more satellites, the fraction grows. Maybe in a century, we capture 1% of the sun's output. In 1,000 years, 10%. The Dyson Sphere isn't a project you announce and build. It's a process that's already underway. And it started the day somebody launched the first solar-powered satellite. But here's the part that ties it all back to the methane nightmare. Don't skip this part. It's the key to the whole thing. Every photon you beam from space back down to Earth, it adds heat to an already overheating system. We've already got a warming crisis from trapping CO2. If we start beaming solar power from orbit down to the surface, we're literally pouring more energy into a planet that's already running a fever. So the real Dyson Sphere play isn't sending power to Earth, it's keeping it in space. Use it up there for computing, manufacturing, running. Massive AI simulations. You send raw data up to a satellite that crunches it for a year on free solar energy and beams back just the results. No extra heat to Earth, just information. That's how you expand civilization into space without cooking the planet you came from. We are building a telescope to look for alien life by hunting for the same gas that's currently blowing up our own planet. That's either irony or poetry. I still can't decide. Here's what I mean. The ELT. Remember, 128 feet across, coming online around 2028. One of its big jobs, analyzing the atmospheres of exoplanets' worlds orbiting other stars. It should be able to spot an Earth-sized planet around a sun-like star. And one of the key gases it'll hunt for is a sign of life, methane, the exact same gas that just blew up in Colombia. But here's the problem that keeps astrobiologists up at night. If we detect methane on some distant planet, how do we know it means life and not just geology? Because right here on Earth, methane comes from both. Biology makes it, geology makes it, cows make it, mud volcanoes make it, permafrost leaks it, ocean floors seep it. So every mud volcano we study right now is literally teaching us how to read the atmosphere of a planet 50 light years away. Honestly, drop a comment below. If we find methane on an exoplanet, do you call that life or just rocks? Doing rock stuff, I'm curious where you land on that. Okay, let me pull this thing together because we're almost at the finish line and I want to bring it full circle. NASA's Artemis program wants to put humans back on the moon. China's aiming for the same by 2030. Both are. Testing in situ resource utilization, fancy way of saying living off the land, mining ice, making oxygen from dirt. But meanwhile, back on Earth, we still can't control the resources erupting from our own planet. Hydrothermal fluids shooting up uncontrollably, methane detonating. With zero warning, Colombia's got over 100 mud volcanoes, Azerbaijan's got over 300. These things pop up out of nowhere and they vanish just as fast. We're planning to mine the moon while our own planet is actively detonating underneath us. That's not an argument against going to space. It's an argument for doing both at the same time. The tech for the moon teaches us about extreme environments. Parker's data helps us predict geomagnetic storms. The ELT helps us understand atmospheres, including our own. And speaking of extreme environments real quick, the space station. It smells like a locker room, I'm not kidding. Astronauts spend most of their day not doing science, they're cleaning. Mold, fixing equipment, exercising just to keep their bones intact. But plot twist, that gross mold, scientifically priceless, bacteria. Up there express genes differently in zero-G. Antibiotics and bacteriophages grown in space develop totally new tricks against drug. Resistant superbugs. The nastiest room in orbit might give us the next breakthrough in medicine. And guess what thrives around mud volcanoes? Extremophile organisms, life that loves the heat, the pressure, the toxic chemistry. Same kind of critters we're hoping to find on other worlds. All right, big picture time. Let me zoom all the way out. The sun drives everything. Its energy powers our satellites, the start of our Dyson Sphere. Its eruptions rattle Earth's magnetic field, potentially shaking. Methane loose from deep underground. Its light reaches the ELT, carrying atmospheric data from worlds we'll never visit. Its radiation eats away at satellites in low orbit but can't touch Voyager drifting in deep space, where a golden record with a baby's cry will outlast every civilization on Earth. These are not separate stories. They never were. Understanding the sun means understanding the methane under your feet. Studying a mud volcano in Colombia is studying how to read a distant world for life. Building satellites is building a Dyson Sphere. Growing mold on a space station is inventing the next antibiotic, Earth. Science and space science are the same science, we just forgot. Now, what should you watch for the sun is near peak activity right now? Solar maximum. If the geomagnetic hypothesis holds, expect more mud. Volcano activity. Colombia, Azerbaijan may be new spots. Indonesia, Trinidad, Romania, all sitting on known systems. Meanwhile, Parker keeps diving into the sun. And in Chile, the ELT rises, getting ready to show us whether methane on alien worlds means life or geology. We are living in the exact chapter where all these threads collide. Now, next video, I'm going to blow the lid off something almost nobody talks about. There's a spot in space called L2, about 1 million miles from Earth, where we park our most valuable telescopes. James Webb lives there, and there's a borderline creepy reason why that specific spot works. It has to do with gravity doing something that, honestly, shouldn't be possible. That's next time. Hit subscribe so you don't miss it. See you there.